Hello everyone. We discuss here third topic from paper 1, that is fundamentals of organic reaction mechanism. Fundamentals of organic reaction mechanism. What is reactions? Conversion of reactants into products. And what is reaction mechanism? Then mechanism is nothing but reaction mechanism is nothing but study of way or path via which reactants are converted into products. That is, in any chemical reaction, some bonds in reactants breaks and some new bonds are formed. Then in reaction mechanism is nothing but study of these processes, that is, which bonds breaks and which new bonds are formed in that process, and whether that old bonds breaks first and then new bonds generated, or new bonds generated first, or and old bond breaking takes place. Which process takes place first and how that takes place, that stepwise study of these processes of involved in chemical reactions, that stepwise study is nothing but reaction mechanism. That is, we know in cricket, replay is there. They study that motion of ball and motion of bat stepwise, slowly. Actually, that movement is fast, but for observing something, they study that process slowly. In same way here, in chemical reactions also, processes takes place very fast, but for study purpose, stepwise study is required for study of reactions, and that stepwise study is nothing but reaction mechanism. And we discuss in this topic some important concepts, important species, important basic concepts required for study of reaction mechanism. Important principles for study of reaction mechanisms. We first discuss use of curved arrows. Use of arrows in chemical reactions. Use of arrow is very important. I already said that in chemical reactions some breaking of bonds takes place and some new bonds generated. What is actually bond? Bond is nothing but electrons, sharing of electrons between that electron pair between that atoms. Then actually bond breaking and bond generation, new formation, is nothing but electron movement. Electron movement. And so as to show this electron movement in reaction mechanism, arrows are required. Arrows are required. And that electron movement in reactions shown by using arrows. And here origin, arrows involve two parts, origin and end. End is nothing but head, and that origin is considered as a tail, head and tail. That origin is nothing but represents from where that electron movement, origin of that electron movement, from where, that is initial place of electrons, is shown by origin of this arrow. And that head shows final position of electrons, that is from where electron moves and up to which point, which center that electron movement takes place. That final location is shown by head and initial location is shown by tail. This is use of that arrows in reaction mechanism. They shows given here 4 rules. You read it carefully. Then next concept is a concept of formal charge on atoms in molecules or ions. In many atoms and molecule, in many molecules, that actually atoms carries 0 formal charge, but in some molecules or in some ions, some of the atoms carry some positive or negative charge, which is known as formal charge. And how that formal charge can be calculated? That can be calculated using this formula, that is formal charge is equal to number of valence electrons in a free state of atom. Number of valence electron. Valence means outermost shell electrons. For example, in carbon, how many outermost electrons are there? 4 electrons are outermost or valence electrons. That is second shell. Carbon have 2 cells, 1s, that is first cell, and 2s 2p, second cell. How many electrons are 2s 2p? 4 electrons. Therefore valence, that outermost shell electrons are valence electrons. In nitrogen how many? 5. In oxygen 6. As like that, valence electrons. Then number of valence electrons in a free state of atom minus, in bracket, number of non-bonded electrons. Number of non-bonded means lone pair electrons, and number of non-bonded electrons plus half the number of bonded electrons, plus half the number of bonded electrons. This is very important formula. Using this formula we can calculate formal charge of any atom in a molecule. For example, on nitrogen, here we calculate that formal charge. Valence electrons in nitrogen 5. Then number of shared electrons in nitrogen, that are total 8 by 2, 8 upon 2, that means 4. And that formal charge is equal to valence electrons minus electron count, that is electron count means that electron bracket electrons. Then that is equal to valence electrons 5 minus that electron count 4. 5 minus 4 plus 1. Therefore valence, that formal charge in ammonium ion on nitrogen is plus 1. As like this, by using that formula we can calculate formal charge on any atom in a ion or in a molecule. You solve some examples, and if any doubt, ask me on WhatsApp or by telephone. Then next is electronic effects in organic molecules. Electronic effects in organic molecules. This is very important part of chemistry, that is basic concepts of chemistry. We discuss electronic effects. There are four effects given, that is inductive effect, electromagnetic effect, a resonance effect, and hyperconjugation effect. These are very important concept principles for understanding of organic chemistry, that is understanding of reactions in organic chemistry. First we discuss inductive effect. That inductive effect is, we know that there are two type of molecules which involves bond between similar atoms. There are two type of bonds considered here, that is bond between similar atoms, that are known as homoatomic bonds, and other are heteroatomic. Heteroatomic means two atoms attached to that bonds are different, that are heteroatomic. Then in homoatomic bonds, that electron pair, bonding electron pair, that bond is nothing but shown here by dash between the two atoms, and that dash, one dash represents two electrons, one, and that bond is formed by mutual sharing, means one electron of this atom and another electron is of that atom, mutual sharing. Then in homoatomic bonds, two atoms having same electronegativity power, therefore that electron pair exists exactly in between that two atoms, because electron pulling power of both atoms is same. But if bond is heteroatomic, then two atoms are different, their electronegativity power is different. What is electronegativity power? It is power of nucleus, remember. Electronegativity is power of nucleus. That is, what is that power? Electron pulling power of nucleus is nothing but electronegativity. And in heteroatoms, electronegativity of that two atoms is different. Then atom which possesses more electronegativity power pulls that electron towards itself. Then what happens? Gain of electron takes place for that more electronegative atom, and loss of electron takes place for partial loss. This is actually not complete transfer of that bonding electron. This is actually slight shifting is there, slight pulling. Then because of that pulling of electrons, that more electronegative atom acquired, there is gain of electron, and therefore electrons are negatively charged, and therefore that acquired partial negative charge. Why partial? Because electrons not transfer completely, only partial shifting is there, therefore charge is also partial, that is partial negative charge in case of more electronegative atom. And in case of less electronegative atom, that is the electropositive atom, what happens? Electron loss takes place, not complete loss but partial loss. Electrons partially shifted towards more electronegative atom, therefore In case of less electronegative atom, that is the electropositive atom, loss of electron takes place, partial loss of electron takes place, which results in formation of delta positive, partial positive charge. Such shifting of electrons from sigma bonded electrons, such shifting of sigma bonding electrons towards more electronegative atom from less electronegative atom is known as inductive effect. This is known as inductive effect. And if here chain length is there, and if that carbon chain for the carbon chain to in for that in that carbon chain, if C1 carbon is, if that C1 atom is here more electronegative, consider it is Cl. Actually this is mistake here, that must be X, that is Cl Bri, as like that more electronegative atom. This must be considered Cl. Then because of that it pulls electrons from C1 carbon. C1 carbon become electron partial electron deficient. Because of deficiency, positive charge of nucleus of C1 carbon increases, then it pulls electron from C2. C2 become deficient, therefore it pulls electron from C3. C3 become deficient, it pulls electron from C4. In this way, inductive effect transfer from that through that chain, but that power of inductive effect decreases as chain length increases. That means on C1 carbon pulling effect is more. That means that inductive extent of inductive effect is more at C1. At C2 it is slight less. Then C3 it is less than C2. As like that, as chain length increases, extent of inductive effect decreases. Depending on that pulling direction, inductive effect are of two types. Inductive effects are of two types, that is plus I effect and minus I effect. What is minus I effect? It is electron pulling effect. That is, out of the two atoms, one is more electronegative and another is electropositive. That electronegative atoms pulls electron towards itself. That pulling effect is known as minus I effect. Minus I effect, electron withdrawing or pulling effect, minus I effect. For example, that minus I effect shown by atoms or groups are here given, that is NM3 plus, NH4 plus, because of positive charge, that are deficient atoms, and therefore they shows property of pulling electrons from other sources of electrons, therefore shows pulling character, that is minus I effect. Then NO2, CN, COH, FCl, Br, I, OAr, esters, alkoxides, alcohols, phenyl, then ethene, and last hydrogen. That means this one is minus I power of minus I effect. That means that power decreases from NMe3 plus to hydrogen. Then plus I effect, then it is donating inductive effect. See here, from one of the atom, for say here X shows minus I effect, but for carbon loss of electron takes place. That means carbon here donate electron to X. Carbon donate electron, therefore carbon shows electron repelling inductive effect or electron donating inductive effect, that is plus I effect. Plus I effect. Remember that here Cl shows electron pulling, means minus I effect, and carbon shows electron repelling, donating inductive effect, that is plus I effect. Then here also they show some examples showing that plus I effect that are shown here, that is C6H5O, that is phenoxy group, RCOO, then R3C, CHR2, CH2R, then CS3, all that groups able to show that plus I effect, that is donating inductive effect. Then applications of inductive effect on bond length. As inductive effect increases, bond length decreases. As inductive effect increases, bond length decreases. Remember that. Atoms comes closer and therefore bond length decreases. Then next is second application. As inductive effect of substituents changes, the acidity of carboxylic acid changes. See here 3 minus I groups are there, electron withdrawing groups are there. Therefore, this carbon to which that 3 Cl are attached, that carbon become highly deficient because their electrons pulled by this 3 Cl, and therefore that deficient carbon more effectively, more powerfully pulls electron from this COH carbon. Therefore, as a result, finally that carbonyl carbon of COH group become more deficient, more electron deficient, and therefore that OH bond strength decreases, and therefore that easily loses that hydrogen, and therefore acidic strength increases as inductive effect increases. Here 3 Cl, therefore more acidic. Here in no minus I group is there, and in acetic acids here, if you compare formic acid and acetic acid, in acetic acid donating group is there, CS3 is electron donating, and therefore that because of electron donation, deficiency of this carbonyl carbon decreases, and therefore it not pulls that electrons from that oxygen, and therefore no effective pulling of that sigma electron which are in between carbon and oxygen, and therefore that bond between O and H is not as weak as in formic acid. Therefore formic acid is stronger than acetic acid. Bond is not weak in acetic acid, bond is not weak as in formic acid, and therefore that bond not easily breaks. Therefore proton, that acetic acid not easily loses proton, and therefore it is weak acid compared to formic acid. Formic acid loses proton more easily than acetic acid because OH bond is weaker in formic acid compared to acetic acid. Then next is reactivity of alkyl halides. Inductive effect also affects on that reactivity of alkyl halides, that is that more reactive alkyl halides more reactive than corresponding alkenes, and because here that bond between carbon and that halide, that bond can be easily breakable. That presence of that alkyl CX bond in alkyl halide, due to which they undergo inductive effect, and therefore that alkyl halides, because of presence of inductive effect. Why alkyl halide shows inductive effect? Because of presence of halide in that alkyl halides, and because of that presence of inductive effect, the alkyl halides are more reactive, because that CX bond is more breakable in alkyl halides. Then next effect is electromeric effect or polarizability effect. Okay, we discuss here for the next lecture.